for the day. I have to actually stream a little earlier and end my stream a little bit earlier today because of some car-related chores that I have to do. I need to go get new tires and blah 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 blah. Not important, but I need to get it done, and the time slot available is 1:30. So I cannot stream from 12 till 3 today, obviously. So I figured I'd start a little bit earlier and get a little bit of streaming in just for the fun of it. Today is a little more of an exploratory day for me. I try to use Thursdays as learning and practice. There's a lot of stuff I just don't really know in the world of programming and Clojure specifically. So I try to pick out topics that I know I need to learn a little bit better. And so that's kind of the idea in general for these sorts of days where I don't have a specific design goal, I don't have a specific library implementation goal, I just have a learning and practice goal. So it's a little more nebulous usually, but I wrote, I'll switch to my screen in just a minute, but I did write yeah, okay, just pulling up Clojure. So I just pulled up the note of things I'm learning. So I want to try poke around Clojure atoms a little bit more, and Clojure atom watchers, as well as def protocol basics, core async if there's any time for that sort of thing. But even before I start poking around and learning, I did want to very briefly showcase the result of the design work that I was doing on Tuesday, which I'm actually really excited about. So I have, to refresh, I was making a design document for parallettes, which are like a piece of calisthenic gym equipment that you can hold and do certain bodyweight exercises on it. And so I had written this document here and produced this basic design here. Bend detail, the idea here was use a grinding disc to cut the slot like this, and then be able to bend some metal flat bar into a triangle piece, which you then weld to a bar here. So the default dimensions that I used at the time were 20 inches long, 2-inch wide flat bar, and so that's it. The design itself is pretty simple. This document itself, I want to edit, add a few more pictures and stuff, and then put on my my GitHub. But I also we actually built it, so I wanted to showcase that a little bit. I also happen to have, well, so this is it in full screen. I also happen to have a slightly different sort of prototype version of the page that actually has this interactive thing right here. So you can change the parameters here, and that results in a different drawing of the elements here. So what we actually went with when we were building this was, so I had drawn it with 20 here, right? And the leg width was 2. The leg thickness was 1.25, an eighth of an inch. The bar diameter we used actually ended up being 1.5. It might have even been 1.315, something like that, because it was a piece of pipe actually, which has some kind of weird dimensions to it. But that's totally fine. The big dimensions that by default I think it was 12 or maybe 10 in there, but we actually went with a 7-inch height for the thing here, which, as you can see, the cool thing about having it interactive is if you want to change the dimensions of the design but you want to keep the design itself, you can just change the globals in this case, and see the effects visualized for you right there. So this is all the reason I call this page a prototype page is because it's not laid out very cleanly. This I would love, instead of typing text into the code block itself, it would be way cooler if you expose some variable control with, say, sliders or drop downs or something like that instead. It would be really nice to hide the implementation, as in the code, altogether. And all these things are possible, I just didn't have a chance to do it yet. But I'm pretty happy with that as a design doc, and the static version as well, which I want to add a few more figures to, but that's working okay. And I have one more thing. This is now a feed of my iPad screen, and I just wanted to quickly show that this is the same site, the active one again, and it works just fine to edit directly on the iPad as well. So it works in a mobile context also. Now, what I just changed here, you can see that this diagram, right? There's no constraints on it or anything, right? You can put invalid numbers in there and you're gonna get weird rendering results, right? So those are things that need to be implemented in a more robust solution. But as a proof of concept, I'm really quite happy with this. And to wrap all of that up, let me just pull up a few pictures of the finished product. Yeah. Okay, so I have here, we made 2 parallettes. Now, as it turns out, since this is a simple design anyway, technically I wouldn't have needed to draw out a document at all. We could have just talked about this and made it work on the spot. But, I mean, that's not great for reusability of design ideas, for updating and iterating designs if you only ever have it in your head. So I wrote down a design doc. But you'll be able to tell there's a few things. One, it's big, heavy, messy stuff. So in general, using metal is fun, but maybe a design like this, I could do something with wood in the future. But I also have a few, this is me using the things too. So they actually work, they hold body weight. So that works nicely. But what I was trying to say is you can tell that here, the point that's being, I thought apologies, let me, yeah. This here, the weld line is very high up on there, where in the original, the tube was here, or in the design I should say, and it was welded low here. But what we actually ended up doing was putting it up here. And the reason for that stems from a few things. One of them being here. I had never done this before as an approach to bending flat bar, but I decided to give it a try. That's not what I need. This. One day I'll learn how to use these tools. Here, this line here, I cut it with a disc grinder and then coped the edges. So just like in the design doc, if this is the flat bar in profile, I ground a spot out like this, and then did this, and then made it look like, as much as I could, like the V here. Now, the issue that came up with that, let's see, where is it visible? Is perfectly clear right here. So this here, let me make sure I'm on that layer. This here is an obviously big problem. The very first bend I did, this corner here, you can imagine, since it was a grinder that we held by hand, instead of this being 90 degrees that I did the cut at, it ended up being a little askew like this. So it was impossible to bend this one straight. So we ended up with this massive problem here. The other thing that, so that wasn't good, but by the end of doing that to 3 other pieces, I was able to get pretty good so that it was, visually it appeared pretty parallel. So even you can tell this is the second one I did, it looks quite a bit better. Now to tie that back in for a minute to the appearance here, where the weld positions are much higher on those tubes, that comes from here. Instead of cutting these legs of the triangles exactly correct, which, let's say the theoretical proper height to cut them at is where those lines are. The original idea was we cut the flat bar about 1 inch longer than we needed, did the grinding positions in their correct spacing, and then the idea was we would visually have this in a jig and cut them to the right height. But what we decided to do was instead just without cutting that excess height, we just put it in the jig and welded it at that height anyway. So there's not a real reason for the discrepancy there. It's purely it was purely a ease of manufacturing decision, right? So this here, it's got a low mount point, but in here it has a high mount point, and that is purely stemming from ease of manufacturing. We don't have all day to make stuff like this. We both, my brother and I, we make these things together. We don't have all day, so sometimes we sacrifice a little bit of beauty in the design to get the prototypes done. Am I fully satisfied with this design? Honestly, no. There's improvements I can make. And that's the beauty of using code, or one of the beauties of using code to create design docs. I can just version control it in GitHub or whatever, and you can see the design progression in the document, and if I take and upload pictures, also in the shape of the actual product that gets built. So just wanted to showcase that for a minute. I'm very happy with how that turned out, and I really am excited to keep using my library and keep building designs and improving even further. So that's my little showcase. Now, what I'm going to be doing next is actually so I'm just going to be moving on here, but I'm going to make a little note for myself. Hey Lumi, how's it going? Done at min 14 or 14-ish. Clip this section later. I don't know if you just tuned in, Lumi. You did way too much theoretical work. You need to clear your head today. I know that, well, I know the feeling of needing to clear your head. I don't know that I would ever have done as much theoretical work as you, but thanks for tuning in. I don't know if you had just tuned in. I spent the first little bit of the stream here just going over the design so on Tuesday I was making those parallel bars. Oh, I just closed it all. But I was showing the result, a few pictures of the actual product. So I showcased it, and I'm just gonna make a little highlight clip of that later. Yeah, you saw it? Cool. It's at least proof to myself that it's not a complete waste of my time to be doing things along those lines, and I was really happy with it. So all I'm doing today, I don't have a lot of time to do the stream. Like by 1 o'clock I have to be gone. I have to put new tires on my vehicle, and the timing of all that just worked out that I have to go at 1:30, so that's why I started a little earlier. But I'm not going to be working on anything crazy anyway. You've mentioned a few times about atoms and reactive atoms and all that kind of stuff, so I figured putting some of that kind of stuff on my list of things to poke around with might be good for the day. So nothing too adventurous, just seeing if I can start to properly wrap my head around some of these things. So I just have a little spot, workbench, where I can just load all kinds of Clojure code and mess around. So the first thing, let's see here. Oh, maybe if I Clojure, there we go. So let's define A as an atom. Right, so that's an atom. You can't just do assoc A, right? Atom can't be, yeah, that makes sense. But I think, what was it again? Is it, yeah. Right, so this, the at A is deref, I guess is what that's called, dereferencing. And then it just pulls out the value at the time. But then this itself here is an immutable thing at that time, right? The only way you can update the map is swap, I think. Swap, and then the atom, and then you want to update it with a function. Let's do assoc A. Does that pass in? No, you have to do it like this, I think. Yeah. So now A, yeah, so if I do at A there, that's that now. Add is syntactic sugar for deref A. Yeah, okay, there we go. Can leave out the nested paren on the swap here. Can you do it just like this? I swap A assoc. Oh, I see. Okay. That's good to know, actually. I'm gonna just put a tiny little note here. Let me see. How do I want to write this? At deref A at A. Then to actually update the value of an atom, use swap. Right, so originally I wrote it like this. Swap A assoc A. But you can write it this way. Swap A assoc A. Let me just double check that that's actually true. Wrong button. Yep. Yeah, perfect. And then reset, I think, is a thing. Reset A. Oh, you have to give it a function still, I guess, eh? Atom new val, yeah. So I could put the new val back as that, and then A is back to being some empty thing. So, okay, let's just see what some of these simple examples are. One thing that so I understand the idea of putting a mutable sort of thing around the Clojure immutable data structures, right? Putting it into a box kind of thing. But for the stuff that I've been writing, it's not immediately clear to me, oh, this is exactly when an atom would be useful to me. So that's the sort of thing I need. So I don't doubt that there are times where it's extremely useful. I just don't have the intuition yet. So if I just kind of poke around some of these examples, maybe some sort of concepts might become a little clearer. But I don't know. See, a little thing with this is I know I need to spend some good time really just actually thinking about and understanding the abstractions and things like that. And that's hard to do on stream, but that's okay. So it's effectively just a variable as you usually have by default in other languages, but it also provides you with observables built in and thread safety. So what are observables? Like what is that Yeah, what are observables? Is that like you can get, no, if the variable changes. Yeah, so I'm aware of that. I just, yeah, I've heard of the concept. Read up on observables. Common in programming. Should learn it. Quote from Wikipedia: "The observer pattern is a software design pattern in which an object, called the subject, maintains a list of its dependents, called observers, and notifies them automatically of any state changes, usually by calling one of their methods." That should summarize it. Okay, so that would be like in an Excel sheet. If your very first cell has some value, and then your second cell is a formula that multiplies that value by 2, and then if you update that original cell, the observer pattern is used in that. It's not exactly the same, there's some extra mechanism. Oh, okay. I think Excel is no, never mind. Anyway, that's a good starting point. One thing this stream is forcing me to do is just write down all of the things I don't know, which is most things. Certainly keeps you humble. Actually, let me be lazy here. Oh. There. Okay, so I thought Excel sheets would be a good mental model, maybe, but there are differences, so come up with different ideas. Yeah, so the add watch function in Clojure was, I have a little thing here, tutorial watchers, because I had heard about add watch before, and I was gonna poke around with that a little bit too. So I had heard about it, I just I didn't realize that I didn't realize that that was called the observable. Terminology is unfortunately sometimes a frustrating thing for me, because there's a lot of terms and a lot of overloaded terms too. So observable, just maybe it had crossed my path before and I just blanked it out of ignorance and frustration. I don't know. Anyway, I find half the time that learning new stuff it's not that some concepts are fundamentally difficult or take a lot of thinking to finally understand, but half the time the challenges I face when I'm learning stuff is just wrestling with my own brain's desire to not want to learn. It's ridiculous. So one thing reset is used to put a new value into the atom. My intuition with this was that it would reset the atom to the same value that you provided when you first created it. However, you need to explicitly pass the new value. This means if you want default data, you have to def it yourself. Right. Does that make sense? That makes sense to my brain right now. So what I mean is begin source Clojure. This doesn't work if you do reset atom. Oh, let me do it like that. I'm all over the place. There. This does reset a So if you want default new data, you could def b. Default b is some empty map, then def b atom default b, and then you would do well, that doesn't really change anything, of course. If you just call reset, you just reset b default b. Maybe there's a smoother approach, but this at least keeps defaults clear. Well, that's good enough for the time being. Let's see here. It's generally a good idea to keep uses of mutation to a minimum, but there are often patterns that would be extremely complicated or inefficient, I should say, to express otherwise. Any program that's not a batch process has to keep track of some information in some way, and that's why we usually end up with at least one atom in an application. Right. And so that the reason I've so far not really thought much about atoms is because the way I've written my rendering library so far is you run it once over the file and it spits out the thing. So it's not really stateless, I guess, if you're doing I/O and stuff like that, but you don't really need to track anything. Now, there are surely things that would make my approach a lot faster. And so that's why I think it's important for me to actually start to understand atoms and stuff like that. But I haven't really had to use them all that much, precisely because any things I've written are probably closer to the script spectrum than they are to the library or program spectrum, if that makes sense, or application spectrum. So this is a step toward a more holistic program, I guess. If you actually have a batch process, an atom may not be what you want. Right. I mean, if it's a set it up, run it once, and then it's done, you probably, depending on the complexity of things, you don't really need an atom. But I eventually want to get to I want to have at least potentially, documents that have elements that the user can change live if they want. And so these kinds of things here, that's where it feels like grasping the idea of atoms, and like you had mentioned a few days ago, reactive atoms. This spot here feels like where it might be more useful. Doesn't require an atom though. For the description of the problem itself. I mean, I suppose not. You'd maybe need it to build the Eclipse framework around it. But the whole idea is to reload everything. Otherwise, you run into weird scenarios. By reload everything, do you mean reload everything in the state, or you mean literally the entire document in one go? I want to be clear, I'm not trying to be dismissive of what you're saying. I am trying to understand everything. Entire document in one go. So I wouldn't. So if we imagine you can snapshot a namespace. Oh, you can also scope capture if that's what you want. That is technically an optimization. Scope capture, snapshot a namespace. These are non-standard terms. Is scope capture like a specific thing in Clojure, or a general principle in programming in general? The idea is to snapshot the current state of the application at a particular line of code. Scope in that sense is that context of the code. Okay. Capture just means store it in some way to restore it later back to that state. I see. I see. It's almost, now correct me if I'm wrong, but it's almost as if it's not like you have a program and state. It's that the program is kind of the state sort of thing. Unless I'm misunderstanding that a little bit. And I'm speaking very loosely here. Yes, exactly. Okay. Cool. In Clojure, this is really easy to do. The program itself, in some sense, is the state, as opposed to a program and state being separate things. Yeah, namespace is just an immutable map in Clojure. Yeah. Right, so you could almost like it's almost like you could just save the namespace, which is the maps. Like you could just like keep saving them to a file or something every time there's a change, and you just accrue these things, and you could go from its most recent thing is your current position, and then you can just go back further to an earlier point in time, kind of thing. Obviously, well, if you were to do something like that, if you go back and then you make changes, now you've got a tree instead of just a sequence. The differences between vars, refs, atoms, volatiles, and boxes are relatively subtle in Clojure. Yeah, that is something that is still a point of confusion for me as well. So like when to use vars, refs, and all that kind of stuff. There's a, let's see here. Let's see, what's there's a search button somewhere in here, right? Oh man, the UI is disappearing. What? Ref. Var. If your program is 100% single-threaded, there's essentially almost no difference except for performance. So vars can store some extra data, atoms can't, and you can't watch a var, and vars support dynamic scope, but atoms don't. Okay. So they become useful for like never mind, what was I saying? In you get different performance characteristics from different things, I guess, if you're looking at doing things in an async way versus a single threaded approach kind of thing. What? There we go. Okay, what else? Why is this? Oh, this is cool. I'm going to put a little note of this actually. You can apply validations. You create atoms. Let's make it an atom that is a map, and the validator is the map predicate. That should work, right? So then reset C with a vector invalid reference state. Cool. You can change the validator after the fact. So if all you want is mutable state, vars, refs, atoms are all the same. Set validator. Right, so I can do set validator iref validator function. So if I do a map, oh, cool. Can you unset validators then? Is that going to be good or bad? Identity. Oop. Huh, cool. Just messing around with that for no real reason, but let me do here set validator a map. There we go. So save that. Oh, see, I actually didn't know if nil was going to be a good I wasn't sure if nil would be the right approach. So nil just removes the validator altogether, I guess, eh? More or less. Remove the validator if you need. Identity is wrong. It will exclude false. If you use identity validator, nil, false is excluded. Okay. constantly true. Do you even need it constantly? Oh, yeah. Yeah, you do. Oh, of course, because it's a function. It needs a function. Cool, thanks for the tip. Yeah. Or constantly true. Constantly true. Yeah, I mean, that makes sense. Any? Clojure dot REPL slash. Yeah, that would totally work. Or wait, would it? Yeah. Yep, good enough. Very thorough testing. Thorough. Okay, so that's some of the basics there. So in Clojure script, an atom is literally just a box. So does a Clojure script atom have like quote unquote feature parity with atoms in Clojure? Because JavaScript is single threaded, right? Technically, yes. I'm sure the implementation is different under the hood, right? But from a user's perspective, the atom works the same. Let's see. Okay, well, those are pretty basic examples here. Compare and set, that looks cool. And add watch and remove watch. And swap vals. What's the difference here? What's swap vals? In any case, the whole point of Atom is that it is a protocol Atom, iAtom, so you can make your own. That's what the Atom in reagent does, which is different from the normal Atom. Yeah, so the reagent Atom, you had mentioned it the other day and called the more general idea behind it is like a reactive Atom. And I started reading about reagent and started poking in at the code a little bit, and currently it's going over my head. Now, I'm not worried. If I give it enough time and study, I'll understand it. But my high-level understanding is that a regular atom doesn't know when it is being derefed, right? Like, or no, I should say, any function that derefs the atom does not know when the atom itself updates. So you would have to update the atom, and then the new value would go in the next time you run the function. But that's with a reactive atom, you have if you've got a function with a deref in it, it will be looking at the state and rerun itself when the state changes, more or less. Now, I might be missing a few things, but that was the kind of high level. Yeah, that seems about right. Oh, I gotta... One downside to having the chat window open on a different computer is I can't pull the link up quickly, at least not how I've got it set up. So I'm just keeping that on a different thing for... I'll have to look at that a little later. Notify deref watcher. Notepad. Boy, oh boy. Well, let's see. Actually, maybe I can get into that a little easily. GitHub.com/reagent project. Reagent blob master source reagent radom.cljs line 144. Okay. Well, now that I've typed it out, let me put it in here. There we go. Yeah, so Lumi, about the keyboard sharing, I know that there is stuff or things that exist, I just haven't set it up yet. Let me put I'm not sure if they work across Windows and Mac OS though. I mean, probably there's something. I know there's some way I could do this, I just haven't set it up. Share mouse or synergy. There we go. I know that if I were doing everything on just iOS/Mac OS, there's like I think they call it the universal clipboard or something like that. If you're all on the same network, you can almost magically get the clipboard. But I've been doing other things instead of focusing on sharing the clipboard. But yeah, something to add. There's always something to improve and add into how things go. Okay. So def type ratom, reactive atom, has an iatom, iReactive atom, equivalent deref, notify deref watcher. They all support clipboard. Oh, they do work across all, but share mouse works best unless you use Linux, of course, because it doesn't support that. It is about 50 euros though. I'm currently not using Linux for my streaming stuff. I do my development on an iMac because I have one, and I had a laptop sitting around. It was cheaper when you bought it, but it's been years. Yeah, prices have a tendency to go up over time a lot in many cases. That's okay though. I mean, I'm willing to spend money for good software. I have no problem with that. Follow the, or have a look at notify deref watcher. Is notify deref watcher a Clojure thing or a reagent thing? I'm guessing it's a reagent thing. Oh wait, this would be reagent dot. Oh, it's CLJS. Right. CLJ. It's a reagent thing? Yeah, okay. So let me, for future here, def protocol, def type, that kind of stuff. All of the code that I've written across the little projects I've done, I don't yet use protocols and types. I just use defin and def and stuff like that. So this is yet another thing that I should, if not ever use it directly, although there must be cases where eventually I'll use it. It's good to know it, and I still don't yet. So, and I say that because if I look through the line of code that you pointed out here, it's using, there's a def protocol for iReactive Atom and def type ratom. So obviously it's a useful way to build things up. Right. Keep that up there. Okay, so this thing caught my interest for a minute here because swap vals. Let's swap the values from A with the, okay, so you swap vals and it does it by applying the function current value of atom to the arg. So if I do assoc, it'll be the same as the other line. Okay, so swap and swap vals. If I reset A like that and then do swap vals, okay. So let me, where was I writing about that stuff? Okay, here. Swap vals will swap, but return to you a vector, or return to you old val, new val, like that. So if I do swap vals, A assoc A B, You could use that to like, well, what would you use that for? You might use it to do a diff or something between the old and new, and then run different functionality based on the difference between the old and new. I'm not sure. It is a tool for abstraction. Technically it's optional. You can program completely without it. Okay. Remove watch, add watch, compare and set. Let's have a look at compare and set for a moment. After I get a drink of water, I'll be right back. Okay. Compare and set. What do we have here? Atomically sets the value of atom to new val if and only if the current val of the atom is identical to the old val. Returns true if set happened, else false. So that would be probably what you need to use in the case of a multi-threaded situation, right? So that you never have two things changing out the state and then just screwing things up. I would guess that that would be what that is. Okay. So you've never used or needed swap vals personally. It is just so you can get the before value. Compare and set is the lower level construct. Swap uses it internally. Okay, that's good to know. I am gonna write just a little example here, just so I know that. Compare and set. It doesn't add anything real. Compare and set was?
Huh, okay. Well, that's fine. Let me have a look at swap for a minute. Source. Oh, I see. Well, whatever. Let's see here. Not compare and set, the one I looked at before. Swap vals, is that what you meant? Oh yeah, that makes sense. Oh, it's right. I just had to scroll up like 7 lines. 10 lines, I guess. 11. Anyway. Yeah, I realize that here. I'm a little too lazy to go and look at it at the moment, to be completely honest with you there. These are all just the, like, they just wrap the Java implementation in the in Clojure functions, basically. Essentially the same, but holds the old value and returns it in the lazy vector. Yeah. Which you could totally implement yourself if you needed to anyway, I guess. I mean, that's true of anything if you really want to get technical, but let's see here. Let's clean this up just a little bit here. Basics. Swap or changing values. Resetting. Validation. Let me check the time for a second here. Okay, I don't have a ton of time yet, about half an hour. That's cool. You could implement it using a compare and set primitive, but this was a non-trivial use case. It was added. Fair enough. I do think I probably won't need to go that in depth for a while with my use of atoms and stuff, so I'm not going to worry too much about it. Let's see here. It is probably won't need to use swap vals much, if at all, but it's there as a bit of an example. Okay, well, let me get rid of this part. Well, yeah, now the next thing here, watchers. Watcher seems interesting. The reset case is covered by swap A constantly and then an empty map. So would reset in general be, if I'm understanding that here, you would just do swap atom constantly whatever val, right? Swap A constantly that, yeah. Right, where val could be whatever you got. Wait a sec. Right, because reset need the paren there. Oh yes, of course, of course. Wait, do you? Am I mixing things up again? Yeah, of course. The reason I was getting confused is because of here. I was thinking it was a scenario like this one here where you can swap A with an assoc, but that's not the same. It's not exactly the same setup. That's why I was confused for a second there. But that's no problem. Resetting. Let me just put this in here for a minute, just because it's interesting. I don't really need it. There. Sure. No reason not to. Just use the whole original thing. Okay, so the watchers is a thing that's a little bit interesting to me because it just seems like a little more complicated use there, but add watchers. Okay, so adds a watch function to an agent, an atom, a var, or a reference. The watch function must be a function of 4 arguments, a key, the reference, its old state and its new state. So whenever the reference's state might have changed or might have been changed, any registered watches will have their functions called. It will be called synchronously. An atom or ref state may have changed again. So use old or new state rather than dereferring the reference. Note that watch functions may be called from multiple threads simultaneously. Var watchers are triggered only by root binding changes, not thread local sets. Keys must be unique per reference and can be used to remove the watch with remove watch, but are otherwise considered opaque. Okay, so the key watch functions are functions that run when an atom or agent var ref changes. They require 4 args, a key, how you refer to the watcher to remove it later. Each watcher, yeah, that's fine for now. I think that's what that means. Add watch, reference, key, function. I'm writing these in the wrong order here. Oh, wait a second. Let me think. Let me think through this for a second. Oh no. I'm mixing up. I was mixing up the signature of the function add watch or add watcher or add watch. This is not what this is talking about. This documentation here is referring to this part here, the function that is actually the watching function. So this is correct. Key, atom, old state, new state. Like that, I'll do that. Well, this is a simple example here. Let me copy it in directly for a minute, and but first, old, new, Arguably the syntax is a bit clunky. Yeah, so every once in a while I run into some functions that aren't, like, to me, I feel like, oh, that does feel a little clunky, but maybe there's a good reason, I don't know. This does seem a little bit like it, but it's not too bad. You usually use a wrapper around it. Fair enough. Do you do like a macro wrapper, or just a function? Just makes it a little easier for you. A new symbol and just keep the handle in a var. Generate a new symbol and just keep the handle in a var. Makes sense? Cool. And then ignore arguments 1 and 2 in the function. Right, so you would do it right, add watch, then a function, old state, new state. Right, you just, oh, it returns the handle symbol then, which you can use to remove later. Huh, okay. Returns the handle symbol. Right, so I get what you're saying. Do you manually managing the cleanup? Yeah. Yeah, that makes sense. If you add it, you got to remove it at some point. This wrapper that you're talking about, is it a def macro and then you use a gensim inside it and then use that, or it's not a macro? Okay. I'm missing something in my head trying to visualize it, but I understand what you mean. Effectively, you can ignore these two things. You make old state, new state, and then you use a separate handle that you've used, and you kind of just ignore the key part of the add watch so that you can handle it on your own instead. That kind of makes sense. I'm not going to wrap it myself. I'm just going to use the defaults for the time being, and then when I discover how I could make it easier for myself, you can use gensim outside a macro. Huh. Nice and easy. It's incrementing by 3, but okay. Yeah, I don't know why. I mean, there might be reasons. I can't think of one why you'd use a gensim outside of a. Never mind. You could use it in functions from time to time. It's calling gensim internally somewhere twice. Is gensim itself calling gensim? I don't think this is going to show me anything meaningful. Yeah. Oh, actually, yeah, that's probably right. Yeah, that makes sense. Anyway, it really doesn't matter, right? It's a generated symbol. Who cares how many points it increments by? Okay, old, new, Right, so here, let me make, well, I already have, let me just do add watch a and call it watcher, just like this function here. Oh, which, by the way, copy link location here. Oops. Oop. Oop, oop, oop. Oh. I am going all over the place here. Ridiculous. I don't need any of that. Suppose I should. That's totally fine. Add watcher, a watcher. Function, right, takes the key in the atom, old state, new state. Print line, string, sure. Oh boy, oh boy. There's a library called Pulsar, which adds full-on actors, reactive vars, and reactive streams to Clojure. Requires a Java agent though. Yeah, see that it basically rewrites all the JVM bytecode. That's a bit above my pay grade. Clojure Pulsar. Quasar Java library with the addition of pattern matching and Erlang syntax. It is written by the same people that are working on adding that stuff to the JVM natively. It's like core async without the limitations and with some alternative APIs and way faster. But it does modify how the JVM works. I've not heard of this. This is pretty cool. Of course, Zach Tellman, his name shows up in a lot of cool places with Clojure. It's not currently maintained, but it does work. That's a common thing with a lot of... it happens in Clojure, but they're too busy with the JVM stuff at the moment. That's fair enough. That makes a lot of sense. It's pretty common just poking around, trying to look at what other people build with Clojure and other Lisp languages for that matter, that a lot of libraries, they reach a working stable point and then they almost keep working without much interference for a long time. Once it is in the JVM, it'll be a mostly obsolete library. Yeah, because then if it's in the JVM, then you get it for free at that point. Well, for free. You get it just by default. I probably am not going to look into Pulsar right now, though. I need to keep my head a little closer into my own capabilities at the moment, you know? It's just to make the compatibility later. That's the project that'll add tail call optimization to the JVM. Don't recommend looking into it, just thought I'd show. That it is cool, but I'm not being dismissive, or I hope I don't sound like I am. That is cool, and I appreciate you showing me that stuff. And tail call optimization, that'll be really great once it's in the JVM. Don't think I'll run into a use case anytime soon. Fair enough. Correct me if I'm wrong, but if there's like proper tail call optimization in the JVM, then we don't need to use they're trampolines, right? Trampolines are like the solution to tail call optimization on the JVM. Am I recollecting that properly, or is that a different concept again? Yeah, no need for trampolines. That should be fun, eh? When we get there. All right, let me add a watcher. I have to get going soonish. I can't stay very long today. But let me see here. String old state. New state. Is this gonna work? Swap from a, the function assoc into a new value c. Neat. Okay, so that does work. Let me put a little thing here. Swap a assoc into b. It doesn't matter. Some new value. There is a prototype implementation already available, so you're hopeful it'll become available within like the next 6 years or so. Yeah, JVM changes, they don't come like that anymore, right? Such a complicated beast. All those things are going to take time. But that will be really cool. Have you used GraalVM at all? Talking about the JVM, I was wondering, you had to add something to the JVM, it's just ridiculously complex. Yeah, I'm gonna not look into it for as long as as long as I can. Maybe that's not true, but it seems like this big black box to me, you know? Yeah, you've used Graal? Graal seems really cool. The only thing I've ever done is tried a little Hello World Clojure program, made it into an Uber jar, and then compiled the Uber jar with the Graal native image thing so that it made a little binary, and it worked, but oh man, it wasn't like Graal build done. It was all these weird things that you had to do. So it seems really cool, and I like the idea of making nice binaries if you can, but I still need to practice that one a lot too. There's always more stuff on the list. Graal VM seems intriguing to me though. I think you're thinking Substrate VM? Graal VM is a new optimizer for the JVM? No, I'm talking about so Graal VM, right? You're right. Graal VM itself is a like you say. Oh, it's part of the Graal VM project. So maybe we're talking about the same thing, and I just didn't know the name of it. Substrate VM. This is what I remember using. Graal VM native image. So maybe we're referring to the same thing. I'm not sure. It's quite confusing. There's also truffle. Isn't truffle like a intermediate language or something like that? I can't remember anyway. But so when I say Graal VM, what I meant was whatever this page is talking about. And that's all I know. At the time I was trying to run it on Windows as well, so there's just all kinds of weird stuff going on. It all can work, you just have to kind of know what you're getting into. Truffle's an interface into Graal so you can develop your language quickly. I see. JavaScript, R, and Python are implemented in Truffle. I see. It's amazing how many layers of languages and compilations and all that stuff there are between, you know, writing some app code or whatever and stepping all the way through everything. I'm sometimes amazed it all works as well as it does. But I won't complain because it's fun and it's cool and can be powerful. Truffle is quite an amazing piece of tech in context, since you're basically just writing an interpreter and you get a compiler for free. That is pretty cool. So I guess Truffle is, it's, maybe I'm mistaken, but if Truffle didn't exist, you could theoretically create the same sort of process by creating a JavaScript interpreter in Java, and then the Graal VM could optimize the Java that you get from JavaScript or whatever, right? Like, it's just instead of
writing JavaScript that goes to Java, you write JavaScript that goes to Truffle. Right? I think that makes sense. I don't know what I'm talking about. Okay, what's another use case for a watcher that makes sense here? Logging. All of these are just logging examples. Non-deterministic. What happens first? Not exactly. The conversion from interpreter to compiler happens in Truffle, but the output is something that Graal understands. JVM bytecode also goes to that same representation before Graal works with it. Oh, okay, okay. I was thinking Graal was working on a different step than it is, or at a different call it layer, if you will. Man, it's amazing. It's absolutely a powerful and cool project. I every once in a while I'm keeping my eyes on it. Okay, add watch. What other functions are related to this? Graal's quite an improvement since OpenJDK is quite complicated C++ code, whereas Graal is all in Java, a much simpler language. Graal uses a shit ton of memory. Yeah, that's true. JVM is already memory hungry. Yeah. There's no there's no such thing as a free lunch or whatever. I have to write a little note here. Probably more things that I can't think of right now. Be aware that order is not always guaranteed on when watches are run. This is because watches are dispatched in different threads. Some programs you need 64 gigs of memory. That is really crazy. So honestly, I thought like you're talking, oh man, there's a lot of memory or it's memory intensive. My brain was like, yeah, if you've got a 16 gig laptop, it'll run slow, but you could make it work kind of thing. But oh man, 64 gigs of memory is yeah, that's pretty intense. And then okay, so the last little bit of note I'm just going to leave myself here is an indication of how to do a remove watch, but then I really do have to get going. My car needs new tires, and I don't want to miss that because you need tires to drive. So, and here in Canada, unfortunately, you kind of need a car a lot of the time because distances are pretty far.
you can remove watch simply by specifying the atom and key of the watch function. So remove watch A, and the key I had was watcher, and that should work. Right, so now if I do that, the watcher doesn't print, or because it's not running anymore. So if I do this and then do the same thing here, old, new, perfect. And then I just remove watch and then swap this back to A, and we're good there. That's awesome. Okay. So this is important to pay attention to because it is your responsibility to manually take care of the watches you set. Yeah, I've been pretty good at distraction again, I guess. Oh, Lumi, don't worry about that at all. The reality of streaming is, well, in general, it is a source of potential distraction, right? Because literally right in my vision here, I've got a text box that other people can put stuff into. So it's an additional source of potential distraction. Def protocol, def type, you should worry mostly about def protocol and reify and def record and less about def type. Okay, that's fair. That's a good point. Reify and def record. Thank you for that. Anyway, I was saying, I'll just wrap this up quickly. Don't worry about distracting me. That's totally a me problem, or a me decision, I should say. I'm still getting my head around the kind of stream I want to run, right, in general, and how effective I want to be, which means I'm recognizing in myself, Monday, Tuesday, I usually have a pretty solid idea as to what I want to do on those days. And I always think that Wednesday I'll be able to use to plan out Thursday and Friday streams really well, but that so far hasn't quite happened. So what happens is I have a rough idea for Thursday and Friday, and then since I don't have enough of a picture in my mind as to what I want to accomplish, it's very open-ended. Distraction becomes really easy. So it's totally not a problem of anyone in chat or anyone watching. Part of the chat is to be able to talk about stuff, right? It's really just a function of me needing to or wanting to approach things a little more effectively in the future. Anyway, so yeah, it's distracting, but that's totally up to me, and I appreciate all the little pointers you give, all the little things to look up. It's honestly helpful because outside of the stream, I do a lot of reading on these things because I want to try and understand things better. I want to actually become a better developer, better designer, better engineer, all of that stuff. And so it takes time and focus. And the streams are just kind of a fun part of that. So anyway, here I am yammering on again. I do have to get going. Thank you so much for tuning in. I really appreciate that. I will be back streaming tomorrow. I think I'll be able to go a little longer than I did today, and I look forward to it. I will be leaving now, though. Have a good day, and I'll see you around.